Okay, so welcome back. So now in this video, we're going to talk about converting. So we're going to do an example of converting from rectangular coordinates to polar coordinates. So we're going to use the formulas to do that. It's very straightforward, very easy. But again, practice so that way you get familiar with it and it becomes automatic. Okay, so the first point is this is x and y, right? So again, we all know this, or you should know this, right? So now I want to convert this to r comma theta. So this is x, y. I want to convert it to r comma theta. So all we're going to do is use the formula. So I know that r squared is equal to y squared plus x squared, or x squared plus y squared. And so this is x is 1 and y is 1. So this is going to be 1 plus 1 squared, right? So 1 squared is 1. 1 squared is 1. So we just get 2. So r, then what? R is equal to the square root of 2. So that's the first one. Okay? So let me write this over here. Okay? So we've got the radial coordinate. So now what about theta? Okay, well, we're going to use the formula tangent theta equals y over x. So y over x is 1, right? So this is just 1. So we have to ask ourselves, the tangent of what angle equals 1? So tangent is opposite over adjacent. So what angle, right? The tangent of what angle gives us 1? Well, a 45-degree angle, right? Which is what? Again, radians, right, is pi over 2. So we know, just based on our understanding of the unit circle, right? So again, if you're rusty on this, review. Make sure you review your trigonometric functions and those definitions and the ratios, the relationships with the right triangle, okay? Make sure you know those. So again, so this is going to be pi over 2. Oops, so this implies that theta equals pi over 2. There's our angular coordinate and we're done. So the answer is going to be the square root of 2 comma pi over 2. Okay, so that's the first one. Oh, I'm sorry. This is 90 degrees, not 45. So this is pi over 4. Sorry about that, misspoke. Okay, so I said 45 degrees, but remember 45 degrees is not pi over 2, that's 90. Pi over 4, oops. So pi over 4 is 45 degrees. Okay, so half of 90, obviously. Okay, so now, what about this one? So we're going to do the same thing. Okay, so now we're just going to use the same formulas. So we're going to say r squared equals x squared plus y squared. So it's going to be negative 3 squared plus 4 squared, which equals 9 plus 16, which equals 25, right? So r squared equals 25, which means that r equals the square root of 5, right? So this is always positive, right? R is always positive. Okay? So we're going to have the square root of 25, which is 5. So r equals 5. So there's the radial coordinate. And so now, again, for theta, we're going to use the formula that tangent theta equals y over x. Okay, so that means tangent theta is equal to 4 over negative 3. So negative 4/3. Okay, so now, so in this case we have to, again, ask ourselves, the tangent of what angle equals negative 4/3? Okay, so this is where, again, we're going to have to use your calculator, okay, because this is not one that is easily gotten from the unit circle. So this means that this is equivalent to theta is equal to tangent inverse, or the arctangent of -4/3. And this is going to give us, let me do it this way. This is, so theta is approximately equal to 2.21. Okay, again, if you put it in your calculator and you take the arctangent, you're going to get approximately 2.21. And so the point would be represented, polar coordinates would be then what? It's going to be 5, 2.21. That's it. Now what about this one? 0, 3. Okay, so you can use this with that, you can find out. Now here's the thing. This, you should know just based on where this point lies. So this point lies on the y-axis, on the positive y-axis. So this is a 90-degree angle, right? So visually, you should be able to mentally visualize this and see that this is going to be 3 pi over 2. Okay? Easily. Without even having to do any work. But let's do the work just to prove it. So again, r squared equals x squared plus y squared. So it's going to be 0 squared plus 3 squared, which equals 9, which implies that r squared is equal to 9, so that means r is equal to 3. Voila, just like I said, right? And then, of course, tangent theta equals y over x, but in this case, it's undefined, right? Why is it undefined? Because x is 0. Okay, so that means x, right? So the tangent of what angle gives us where it's going off to infinity. The tangent is going off to infinity, where we get x in the denominator. Well, that's going to be when x is 0. What happens when x is 0? What angle? It's 90 degrees, right? Because again, we know where this point is. It's on the y-axis. Okay, so it's right between the first and second quadrant. So we know this is going to be, so this is going to imply that theta, let me make that better, equals pi over 2. So that means our point is going to be 3, pi over 2. Okay? Okay, so that's that one. So now the next one, we have what? X is 5 root 3, and y is -5. So again, let's do the same thing. Okay, we're going to do r squared equals 5 root 3 squared plus -5 squared. And so what does that equal? Well, this is going to equal what? Well, this is 5 times the square root of 3, right? So this is going to be 25, 5 squared, right? And this is going to be square root of 3 squared. So this is going to be what? How do we handle that? By using the properties of exponents, right? So this is going to equal 25 times 3, because we're going to distribute the square, right? And then this is going to give us 25. So this is going to give us 75 and 25, which will equal 100. So r squared equals 100, which means r equals 10. Oops, not 11. 10. Okay, so now let's do the tangent, right? So tangent theta equals y over x. So it's going to be negative 5 over 5 root 3. Which equals what? 1 over root 3. Okay, so now here, what do we get? What angle, the tangent of what angle equals 1 over the square root of 3? Well, again, all you have to do is remember your right triangles, right? So opposite over adjacent. So what kind of triangle has 1 in it, square root of 3? If you think about the unit circle. Well, this is going to correspond to what? A 30, 60, 90 triangle. So what opposite leg over adjacent leg? Okay? So this is a 30, 60, 90 triangle, which means this is going to be what? What's the angle? It's going to be 30 degrees, right? $30 degrees. So this now here's the kicker. Okay. It's a 30 degree angle, right? We know it's a 30 degree angle, right? Just do the unit circle or the unit square, not unit square. Think of the unit circle and do your right triangle. So we know, oops, sorry, negative. So we know that's a 30, 60, 90 triangle. And so we know the opposite of this angle, so theta, this is 1 over the square root of 3, which means what? This is going to be 30 degrees and 60 degrees. And so this is going to be 2, right? So it's 30, 60, 90. Okay? Now, but here's the thing. What quadrant are we in? This is negative, right? This is positive, negative. Okay, we're in the 4th quadrant here. So, in other words, this is what we're looking at, right? So, this is 30, 60, 90. So, this is going to be what? It's y negative 1. And this is square root of 3. So that means this is 30, but we're going all the way around. So what's theta? Okay, theta is the distance around. So if this is 30, right? So we could be negative. So this would be negative, right? Because you're going the opposite direction. So again, this would be negative pi over 6, or if you wanted to go the other way, it would be 5 pi over 6. Or excuse me, I'm sorry. 11 pi over 6. Okay, same thing. Okay, but in this case here, what we would do, this would be 10, comma, negative pi over 6. Okay, but realize 11 pi over 6 is the same angle. Okay, and that's it. So now in the next video we'll do an example where we're now going to go from polar coordinates to rectangular coordinates, and that's where the other formulas come in. Have a great day.